Or we can write this as P2, okay, because they sold one more unit of P2, so 1 times P2, which is just P2, okay, minus P1 minus P2 times Q2. Times Q1, sorry. Times Q1. Okay? So that is their marginal revenue. It's no longer so simple as just using price. It's got two components. It's got two components. More generally, you can write if revenue is P times Q, but Q is itself a function of P, right? Because demand's downward sloping. Then we can rewrite marginal revenue as P plus Q times dP dQ. P times, I'm sorry, times dP dQ. Okay? P times marginal revenue equals P, what did I do wrong there? Times Q. Oh, I see, yes, of course, that's what I did wrong. That's what I did wrong. Okay, so it's Q, it's Q times P of Q, that's what I did wrong. I see, so it's P plus Q dP dQ, that's what I did wrong. I set the initial line up right. I had this line right, I set the initial line wrong. So price is a function of quantity, because basically if you want it, the price is, if you want to sell another unit, you're going to have to lower your price, of course, that's what I did wrong. Price is a function of quantity. If you want to sell a unit, you have to lower your price. So it's P plus Q dP dQ is the marginal revenue. So what this means is if you want to sell another unit, your marginal revenue is two components. The first component is the fact that you sell another unit, so you get P. The second component is you have to lower your price on all your previous units. So while this is positive, since demand slopes down, this is negative. While this is positive, since demand slopes down, that is negative. The intuition here is what I like to call the monopoly poisoning effect. It's not a technical term, it's what I like to think of it as. The monopoly poisoning effect, which is by selling another unit, I poison all my previous sales. Right? Because in order to sell it, I've got to lower my price. And by lowering my price, that means I make less money on all my previous sales. Okay? So the monopolist has this tricky feature of marginal revenue. It's not just price anymore. It's now got this extra unit. And what's driving this, of course, is my uniform pricing assumption. Okay? The fact that, in other words, since it's uniform pricing, I've got to charge the same price to everyone, that if I want to sell one more unit, I'm going to give a price break to everyone I sold to before. So the marginal revenue term is now much more confusing than it was before. It's not just simply price. It's now price plus quantity times dP dQ. Why is this not true in perfect competition? What happens to the second term in perfect competition? This is 0 in perfect competition because they're a price taker, right? This term, mathematically, this is true. This is just the derivation. Okay, as difficult as it was for me, this is mathematically true. Okay, the difference for perfect competition is that term is 0. But it's not 0 for monopolists because it faces a downward sloping demand curve, so there's this poisoning effect. So what that means is that we can graph the monopolist's marginal revenue curve as in figure 14.3. That the monopolist actually has, just like the competitive firm has a marginal cost curve, but then just the price that's given by the market, the monopolist has not only a marginal cost curve, but a marginal revenue curve. So here's one example. Demand is 24 minus Q. Okay? So in this example, price equals 24 minus Q. We can invert this, okay? We can invert this to rewrite this as, no, we can just leave it. We can just say revenues are P times Q. So P times Q equals 24Q minus Q squared. I just multiplied through by Q. So marginal revenues are 24 minus 2Q. So marginal revenues are 24 minus 2Q, which, as you can see, starts at the same point as the original demand curve, but now has a steeper slope. So the marginal revenue curve lies inside the demand curve. Now, in fact, the fact it starts at the same point is an artifact of the way we set this up. But basically, and the fact that basically it's twice as steep is sort of an artifact of the structure of this. But the general structure is going to be that marginal revenue curve will be steeper than the demand curve. The general structure is that the marginal revenue curve will be steeper than the demand curve. Okay? Now, note for a second the important relationship between marginal revenue and the elasticity of demand. Okay? So we're going to take this equation. Now let's take this equation, okay, which is marginal revenue is P plus Q times dP dQ. Now let's remember the definition, and what we're going to do is we're going to take that equation, we're going to multiply and divide by P. Multiply and divide this equation by P. So you get P plus Q times dP dQ. If you multiply and divide the equation by P, you're going to get P plus PQ times dP dQ over P. Okay, which you can rewrite as P plus P times dP dQ times Q over P. Okay, dP dQ times Q over P. Okay, now this term should look familiar. This is the inverse of the elasticity of demand, the elasticity of demand. Flip this around, dQ dP times P over Q, that's the elasticity of demand. So we can rewrite this equation as P times 1 plus 1 over the elasticity of demand. P times 1 plus 1 over the elasticity of demand. Okay, so marginal revenue equals P times 1 plus 1 over the elasticity of demand. Okay? Now, think about the implications of this. What is the elasticity of demand facing a firm in a perfectly competitive market? The elasticity of demand facing a firm in a perfectly competitive market is what? Don't raise your hand and tell me. What's the elasticity of demand facing a firm in a perfectly competitive? Yeah. No, bigger than that. Negative infinity. Negative infinity, it's perfectly elastic. It's even bigger than that. It's perfectly elastic. Negative infinity, so what's marginal revenue? P, right? So once again, this shows the extreme. Now, if you take, on the other hand, if you take a firm that's got an elasticity of demand of -1, what is the marginal revenue? 0. So if elastic demand is -1, marginal revenue is 0. Why is that? If the elastic demand is -1, why is the marginal revenue 0? If the elastic demand is -1, what's the intuition for why the marginal revenue is 0? The marginal revenue, so what we're saying is a monopolist who sells another unit makes no money if the elasticity of demand is -1. Why is that? Yeah?
Because the C and B areas on that graph are going to be equal.
They're going to be equal. The amount you're going to lose from lowering your price is going to equal the amount you're going to gain from selling another unit because the elastic demand is -1. Okay? So you're going to get a marginal revenue of 0 if the elastic demand is -1. Because the poisoning effect is exactly going to cancel out the benefit of selling another unit. Okay? So this handy formula lets you understand how basically you can get marginal revenue as a function, this marginal revenue curve, as a function of the underlying demand curve. Okay, the function of the underlying elastic demand. Yeah?
If there's no benefit, why do people increase their prices there?
Well, so basically, well, that's the question. If the elastic demand was -1, then you'd say, well, what pins down, if the marginal revenue is 0, then I presumably the marginal cost is greater than 0. So I presumably would want to reduce the level of production. But at some point, and what happens as I reduce the level of production? As I reduce the level of production, as I reduce the level of production, I'll move back up that demand curve, and the marginal revenue is going to raise back above 1, go back above 0. So I'll equalize marginal revenue, marginal cost. Okay? So basically, so basically, you can see that you're going to get what the monopolist is going to make and what their marginal revenue is going to be as a function of how elastic demand is. The key is, for the firm, This elasticity demand is the elasticity, this is the elasticity facing the firm. In a perfectly competitive market, that's one little guy. In a monopoly market, that's the whole market. Okay? And that's the key difference. Questions about that?